eluding IDS. This is what we call an insertion attack. It's based on the fact that IDS and target hosts see two different pictures, two different packets, because the IDS sees extra packets. So when a big stream of packets is sent, let's say in this case we've got several packets being sent. We've got the P, for all intents and purposes, let's just assume that this first packet has a P, an A, an S, and then the next packet has a P. The first packet has a P, the next packet has an A, the next packet has an S, and then there's an E, an S, a W, and a D. Well, the sniffer, the IDS, will see all of those packets in a string. It will not see anything suspicious. But after that packet flows through a router and the TTL is decremented, the packet in the middle, the E packet there, which had only a TTL of 1, will be discarded. So the only packets that actually make it to the host are the P, A, S, S, W, D. If you notice, the key thing to look at here is the TTL underneath the letters. All the others have 20s, but that one packet has a 1, which means the next router it hits is going to throw it away. If there's a hop between the IDS and the target, then the target will see all those packets except those which have the TTL1. Now, if you can space these single TTL or just a very short number of TTL packets in between some other packets, you can sort of hide the data by spreading it out over far too many packets, and the IDS just can't construct it and make any sense of it. So that's called an insertion attack. Here's some more eluding techniques. First of all, you can use denial of service attacks by starving the IDS for CPU utility, or you can max out its memory that's available, or you could possibly, and this is more popular, to max out the bandwidth that's available. If you can saturate an interface, and remember, it's a difficult job already. If there are 10 or 20 machines all on a segment, all blazing away, that one IDS has to be able to interpret all 10 machines' traffic over the same bandwidth interface, most likely. Now, that is a difficult task in itself, and some packets are going to have to get dropped. And if you can further saturate and perturb the problem, then that's certainly will reduce the effectiveness of the IDS. When an IDS is used in line or in an otherwise active mode, the attacker uses an IDS against the owner by causing what we call a self-induced denial of service. In other words, by spoofing a legitimate host, we can cause the IDS to react to legitimate packets instead. So the IDS itself will become the wall and will start, because it sees anomalous or signatures coming from a legitimate host, it will block off that host or take some action against it. The single largest reason most organizations are hesitant to use active or reactive IDSs, because they will detect an anomaly and then quickly react to it by perhaps creating a rule in a firewall saying block this type of packet. Well, if they block the wrong type of packet, they very well may shut down their own network. Okay, further eluding techniques are by using encryption. If the packets are encrypted, there's not much the IDS can do about it, other than detect the fact that it's encrypted. Without knowing the key for the encryption and the type of encryption, the encryption algorithm, there really is no way for that IDS to look inside that data any further. So here we have some encryption schemes like using VPNs or SSL or IPsec, and here are some encryption algorithms like Blowfish, AES, or Triple DES. There are also some proprietary means of encrypting traffic. Either way, if it's encrypted, the IDS won't be able to see the contents of those packets.